Okay, in last class, we are trying to connect to SnowSQL through the command line interface, but we are facing some issues. So I get it resolved today. We'll see how to connect. So SnowSQL is the command line interface. This is the Snow site. We call this as Snow site, and the command line interface is SnowSQL. So the other day I have shown you, we have to download the SnowSQL. I have already downloaded this. Based on your operating system, you can download the required version. You can download the required version and then go to command prompt. Let me exit this. If the NoSQL is already installed, it will show the version, what is available version here. So it is giving all the options. NoSQL hyphen version. Say 1.2.32 is the NoSQL installed on my system. So I have to connect with this through the credentials. So in order to get the credentials, we have to go to our account, click on my profile. Sorry, not my profile. One second. Go to your account. Over on this account ID. This is the current account which I am using. If you click on this, here you will get the link. Copy account URL. Copy this. Paste it in a notepad. I have already pasted. This is my account URL. So this would be my username. The first code followed by the region. This would be my login name. So here, SnowSQL. Account name is this one. And also we have to provide the username. This is my username and this is the account name. If you want to get your account name, do the same. Copy the link, paste it in a notepad, and the code followed by the region is your account name. So it is asking for the password of your Snowflake account. So now I am successfully connected to the same Snowflake account which we are accessing it here. Let me see what are the available databases. So first let me see what is the available role. Select current role. So at the end of every query, we have to put a semicolon. Okay, spelling mistake. So currently I'm using the account admin role. So if you want to use any other role, you can execute the same command, use the role or your required role name. So currently I will go with the account admin itself. So now I'll use the database. Use database. Database name is testdb sysadmin. So now the database is already set. See, if you see here, the database is system admin. TestDB system admin. And the schema is public. If you don't select any schema, it will be by default, it will be public. So if you want to select schema, use schema. The schema name is TestDB. Sorry, test schema sysadmin. You have to put semicolon at the end of each statement, otherwise it will treat the query as incomplete. So now the database and schema are set. Now we can query the tables. Let me see what are the tables available here. Show tables. What it has given. So I think it has given the table name along with the data available in that. No. Created on name database. We are not comfortable reading the data here, but what it will show is show tables. Let me switch to account admin. So this is what shown in the command line interface as well. Created on name, database name, schema name. Everything is displayed here. The same data, but it is not a readable format. It is pipe separated. These are the headers, and this is the data available inside that. Now I'll query the table. Let me see the table names from here. I'll query this employee table. So these are the three rows available in the employee table. So whatever you can do using the UI, the same thing can be done here using the command line interface. So this is how you can connect to command line interface and execute the queries. There is no difference. You can execute with either UI or the command line interface. Anything is fine. So this is how we can access Snowflake in two ways. One is through UI and other is through CLI. Now this is just the platform, either command line or UI. This is how we can connect and run the queries. So coming to the next part, these are all theoretical concepts now. Micro partitions. So whenever we are loading data into Snowflake, either from S3 bucket or through any source, whenever the data comes into the tables, the data will be partitioned into some small units. So those are called micro partitions. So if the data size is less than 1 terabyte, the Snowflake will automatically do the micro partition based on the default key. I mean, it will assume some of the data available in that as the default key, and it will do the distribution into micro partitions. So each micro partition is of size 50 to 500 MB. Each micro partition will hold data of size 50 to 500 MB. So Snowflake automatically does that micro partition based on the automatic compression and everything. We don't need to worry about that, but we just need to be aware that Snowflake's data is on the background divided into some small units, which we call it as micro partition. These micro partitions will hold the metadata. Let us say now this employee table is small. We have only 3 rows, but let us say this employee table has 1 million rows. So, as I said at the beginning of the Snowflake, that it is a columnar data warehouse. Snowflake is a columnar data warehouse, whereas traditional Oracle database, they're all row based. So, because of this columnar storage, each micro partition will store a columnar data. One set of column is stored in that micro partition, and also it will store the metadata. Now, if you look at this data, here we have a date of joining, salary, first name, ID. So each metadata, I mean each micro partition, when I say micro partition, it will hold columns, nothing but the columns. Let us say we have 10 million rows here. The one partition will hold around 1000 rows, I mean 1000 IDs, 1000 IDs available in a column. So in each micro partition, it will hold what is the minimum ID. Let us if we take the ID column. In this column, the minimum value is 101 and the maximum value is 104. So based on the minimum and maximum values while querying the data, if we apply a filter on this table where ID, let us say we have 10 million rows, the numbers will be 10 million. When I say then ID between 100 and 1000, so it will directly go to that partition where these IDs are stored. So on the background, It will for each it is not possible to show, but it is a concept we have to be aware of. So each partition or each micro partition will hold a metadata like what is the minimum value stored in this, what is the average value. It will store all the statistics, maximum value, minimum value, average value. So whenever we query, if we query based on this ID column, then it will directly go to that micro partition instead of scanning the whole table. Uh, Let us, if we are doing the if we are querying on the date of joining table, so let us say 10 million employees, and this is about 10 years of data, or 10 years of data. So each micro part two, let us say we want 2 years of data, not 2 years, let us say for 1 month of data. The data is arranged based on this column, based on this date of joining column. So let us say we have data from 2000 to 2020. 20 years of data we have it, 10 million rows. So the data will be arranged in the ascending order of this date of joining, and there will be some 100 or 1000 partitions on the background. But when I write a query, while the date between some 2010 to 2011, instead of scanning the whole table, first it will read the metadata of the micro partitions. Uh, Once it has fetched the metadata of the micro partition, then it will go. If the metadata is satisfied, let us say we are querying 2010 data, and it is reading the metadata of the table. It has 1000 micro partitions and it will not scan all of them. It will just read the metadata. And if that date is falling in between the date available in the metadata, then it will go inside that and do the actual scan of the data to get the results. So with these micro partitions and arrangement, the data retrieval will be faster. I mean, the performance will be efficient. This is how on the background Snowflake stores the data in the micro partitions. It will store column wise, and on top of each micro partition, it will hold the metadata. Based on that metadata only, our queries execute. Even when we take the salary also, it will take the minimum, maximum in each partition and will give the results easier. So most of the times in Snowflake, we go with the automatic micro partitions or automatic clustering. Micro partitions are the units, I mean storage units. When I say clustering, clustering is how the data is distributed. In an employee table, we have these columns: ID, name, date of joining, salary. We can define clustering on any of these tables. So on whatever the table we define clustering, the data will be arranged based on that clustering key column. If I am aware that my table, this employee table, will be queried frequently by applying filters on the date of joining. So most of the times, 90% of the times in our organization, most of the people will query this data by applying a filter on this date of joining, where date of joining between 2010 and 2011, like that. If the people are using date of joining as the cluster, I mean, as the filtering condition while querying this table, then we have to define this as our clustering key. In that way, our query becomes efficient. So this employee table is already created. If we want to define clustering on that table, we have to do it like this. Alter table employee cluster by. So whatever the column we need. Cluster by date of, I want to cluster by date of joining. We won't be able to see any difference here because the data size is small. We can define clustering on multiple columns as well. So let us say if we are using two filters, uh, if we are using two filters in our query very frequently on the salary part as well as the date of joining, we can define multiple keys also as the joining key. Sorry, as the clustering key. So for the already existing table, we can define clustering like this. So now the clustering. Now the data is sorted based on the date of joining and the salary in the employee table. The data is rearranged based on these partitions. I mean, based on this clustering. So if we want to define anything, we can do it like this. Otherwise, if we don't, till now we have not defined any clustering columns on the tables we have created. Snowflake automatically took care of that. We don't need to define anything. But if the data size is so huge, then only we can go with uh, manual clustering. So this is about the clustering. Most of the times in interviews, they will ask what is the micro partitioning and how we can do the clustering over a table. So micro partition is nothing but small units of data. It is automatically generated by Snowflake. Whenever we load the data, it is stored in micro partitions on the background. And clustering is by default, Snowflake will take care of that. But if we want to do it manually, we have to do it like this on the most frequently. On what basis you can choose the clustering keys is the most frequently asked interview question. We can choose based on the most frequently accessed column. If, see, let's say date of joining and salary are same for 100 employees, then all these data is stored in a same micro partition. Similar data is arranged together and also it will be sorted. This is about the clustering, and there is one more theoretical concept called cache. So cache, it is not generally the system cache we whenever we fill an application, it will take username, phone number, email ID, something, all the details it will take. So whenever we are trying to fill and one more application in the same computer, it will uh, show the results. It will show the suggestions. So let us have the Snowflake account. It is already logged in here, but whenever I try in a new browser, it will show the username and password suggestions, the same details whichever we have used. That is all because of cache. So similarly, in Snowflake also we have a concept called cache. So whenever we run the query, now we have run this query, select star from employees. So for the first time, it will scan the whole table and get the result for us. There are three types of cache. First, let me tell that. One is result cache, other is metadata cache, and one more is data warehouse cache. Sorry, not data warehouse, warehouse cache. Warehouse cache is also referred to as local disk cache. So when this result cache is like whenever we run a query, Snowflake will store those results for the next 24 hours. The results will be stored for the next 24 hours. For the first time, it will scan the whole table. When I run the next, I will run this same query again. First time it has taken 0.735 seconds. I will run this query again. Some little bit has reduced 727 seconds. Initially, it took 735 and later it is 727. This table is so small, we cannot identify the difference. See, again 0.134 seconds. It has reduced a lot. I will query it again. So the time has reduced because it is not actually scanning this table. For the first time, it is scanning this table, and the next time, here, first time 735 seconds, next time it has taken 0.727 seconds because there is not much difference because we have done some changes on this table. See, we have added a clustering key. That's why if any changes are made on the table, again it will read the whole data. If there are no changes from this query to this query, there is a change called clustering. Clustering happened in between these two queries. That's why it has again read the whole table. After this query, we did not change anything. That's why the time has reduced a lot. This is small table. It has come from 0.7 to 0.1. Assume a big table which has large data. So let us say if the query is taking initially 10 minutes. On the second run, it will take hardly 1 minute because it is not actually reading the whole table. Instead, it is getting the result stored already in the cache. So whenever we run query for the next 24 hours without considering there are no changes on the table in between. If there are any changes, then again it will read the whole table. I will do some updates or inserts into this table now. Insert into employee values. ID is 105. Name is Jacob. Date of joining. And salary is 35,000, let us say. I'm inserting one more row. Now the select star has taken 0.134 seconds when I run it for the second time. I mean, when there are no changes, it is fetching results from the cache. Now I'll run this query again. Select star from employee. See, the time has increased. Again, I'll do one more update. Update employee set ID equal to, I'm changing these ID columns. ID plus whatever is existing, I'm incrementing 2 to that. I'm updating the whole table. So now I will query this table again. This is small table. We are not able to see the much difference, but from here you can see the difference. Whenever there is an update, it will scan the data again from the table. So that's why it has took some more time. Only the change data it will take from the table. The remaining data it will take from the cache. So this is how the cache works. Result cache will store the results for the next 24 hours. Let us take some big table, Snowflake sample data. Customer table. Customer table has how many rows? It has 65 million rows. Let us do select star from with some limit. It has taken 445 milliseconds. I will run this again. See, 445 to 55 milliseconds because I am running the same query again. But if I update this data, again the table, the query execution time will increase. Let me apply some filters here on some date column. Okay, I will apply filter on birth year where the birth year equal to 1942. So it has retrieved 907 K rows with 3.8 seconds query execution time. Remember this query execution time. The rows will be same because I will be running the same query. 3.8 seconds initially it has taken. I'll run it again. So 53 milliseconds. Initially it was 3.8 seconds. Now it is 53 milliseconds. So this is the concept of result cache. It will store the results for the next 24 hours. If there is no change in the data, it will get the result directly from cache. Otherwise, if there is change in data, it will scan the table again. So another thing is metadata cache. Metadata cache will store the headers along with the minimum and maximum values present in that, or the table definitions. Everything related to metadata is stored in the metadata cache. Uh, Let us say if we run the count of star from this table, I mean the count, minimum, maximum, these are all metadata. So I want to see the count for this table with birth year 1942. So this is all stored in metadata cache. So even if we don't run the query, initially also, how many rows are there in this table, that will be stored in a metadata cache. The count of star, minimum value, maximum value of each row, that is already stored in the Snowflake. This is called metadata cache. It has taken 328 milliseconds. Even if I don't apply that filter, I am not applying this birth year filter, running the query again. So it has taken 69 milliseconds. Though we did, this table is so huge. It has 59, 60, 65 million rows. But this count is a metadata. That's why it is not taking a lot of time. Count, minimum, maximum. These are all the metadata columns. That's why the table won't take much time. The query execution won't take much time. So this is while running the aggregates like minimum, maximum, count, the results will be faster because of the metadata cache. And the other thing is warehouse cache. Now I'm using this warehouse, compute warehouse. So whatever I run the queries available with this warehouse, all the results will be stored until I suspend this warehouse. So that is called warehouse cache or the local disk cache. Yeah, I am not going to suspend this warehouse unless there is a auto suspend option. But this is a default warehouse created. We haven't defined any auto suspend here. So auto suspend is like whenever we are not using the warehouse for 5 minutes or 10 minutes or the defined time period, the warehouse gets suspended. So before it gets suspended, whatever the queries are run over this warehouse, it will store all the results. And similarly, like results cache, if there is any change in the data, it will again read the table. Otherwise, it will give the same results. So this warehouse data is also called as local disk cache. These are the three types of caches available in Snowflake. So yeah, this is pretty much I have covered all the topics. Any questions for you?
No, only.
Okay, so I will tell you what are the important concepts you have to prepare for interviews. Snowflake architecture. This is the most important question. Without this question, there will be no interviews, I can say. Architecture of Snowflake. Difference between Snowflake and other traditional databases. Next, Snowpipe. These concepts are very important. Snowpipe. How do we ingest the continuous data? Using Snowpipe. Task, stream, time travel. Next, failsafe. Now what we have discussed. Cache, micro partitions. Architecture and these differences are the most important. Without these questions, so we cannot expect an interview. So micro partitions, also stages, internal stage, external stage, data copy, data sharing. Data sharing I have discussed in last class. Data sharing is like even though if the user is not part of our organization or he don't have access to this table, but he wants access. So during that time, we can get the account ID of that person and do the data sharing. Even though they don't have a account in our organization, they can access it with the data shares. So these are the important questions will be asked. You have to prepare for this. Let me know if you have any questions.